Hey everybody. Um, so let me do a little bit of explaining on how this is going to work. Um, Obviously, I'm recording my lectures, and it's going to be important for you to watch these. You'll have a hard time doing the worksheets, figuring out homework, all that, unless you pay close attention to these. I should give 99% of the information that you're going to need on those in these presentations. With that said, we are halfway through the chapter right now. We just finished up, before all this went down, we finished up the flowers section in this chapter. This chapter is over flowers and fruits. So we finished up the flowers section, and we're now getting into the fruit section. The fruit section's lengthy, so it might take you a couple days to get through today's discussion. But just be aware, you need to watch these. You're going to be required to take very detailed notes on these and put pictures of your notes on Canvas. And we're looking at homework is going to become the staple of this classroom, meaning you're going to have to do a fair amount of homework, more than I think than we did before just in class, and as that homework's going to be worth more. I'm going to make it worth quite a bit more than it was before. So it's really important that you take notes over the stuff that we're discussing here, and really important that you post those before the due dates, because I'm going to set firm due dates, and when that due date is done, it's done. You can't turn it in after that point. You'll receive a 0. Anyway, I'm going to go ahead and get started right now on fruits, and hopefully this goes well for all of you, and hopefully you can figure these things out. So, in order to understand what a fruit is, you need to understand flower structure. So we've already learned about flower structure, right? The shape and the structure of a fruit is directly related to the shape and the structure of its flower. Really important idea there. So if you understand it, the idea that whatever a fruit looks like, or however a fruit is structured, its flower had the exact same structure. The ovary of the flower had the exact same structure. What is a fruit? Definition of fruit. A fruit is an enlarged ovary. When you eat a fruit, and I know this sounds really strange, you are eating the ovary of a plant. Or you are eating a part that is around the ovary of a plant. It's one of those two things. But most of our fruits, or many of our fruits I should say, you're actually eating the ovary of that plant. That ovary has just grown huge, from a size that is maybe like the head of a pin to, that big, right? Like an apple or something. It's a mature, developed plant ovary. If you recall, here's the ovary. And within the ovary, you have the ovules. And the ovules will develop into the seeds, and the ovary becomes the fruit. Only angiosperms have fruit. We talked about other categories of plants when we talked about flowers. So there's angiosperms, and then the other big category is the gymnosperms. If you recall, the gymnosperms are cone-bearing plants, such as pine trees. Angiosperms are flowering plants, and sometimes the flowers are non-showy, which means they really don't look like a flower, but they are. They don't have petals. So here's a kind of something that'll help you to determine if something is a fruit or a vegetable. If it has seeds, usually it's a fruit. So let's talk about some vegetables. Sometimes we mistake a vegetable for a fruit, and many times we mistake a fruit for a vegetable. If you've been taught that your definition of a fruit is it's got to be sweet, usually. Lots of fruits are, but there's also many, many, many fruits that aren't sweet at all, not in the least. And so, if you look at it this way, if it's got seeds, it's a fruit, okay? If it doesn't have seeds, a lot of times it's a vegetable. So let's talk about vegetables for a second. Lettuce, no seeds, okay? Onions, no seeds. Celery, no seeds. Carrots, no seeds. All those are vegetables. Potatoes is a vegetable, no seeds. Well, let's talk about some that you may not realize are a fruit because we normally talk about them as a vegetable, right? For example, all squashes, they're a fruit, okay? So a pumpkin, or, you know, a lot of times we think watermelon's a fruit because it's sweet, and a pumpkin, well, that's something else. It's not a fruit, it's like a vegetable because it's not sweet. It's got seeds, it's a fruit. Green peas, beans, all of those are considered fruits. Really strange, I know. And for some people, they have a hard time grasping this. Now, this is all botanically speaking, right? So, you know, you go out in society, maybe you still call them a vegetable. Or even some students argue with me, they're like, oh, but on the food pyramid, it has vegetables, it has beans as vegetables. Okay, fine. Because non-botanically speaking, people usually consider a fruit to be sweet and a vegetable non-sweet. But for this class, anything that's got seeds is considered a fruit. Okay, fruits or fruitlets develop from nowhere. So what's a fruitlet? A fruitlet is a tiny fruit. So for example, a raspberry is made up of many different fruitlets. Okay? Each one of those fruitlets developed from an ovary. So think about that for a second. A raspberry, each little section of a raspberry or a blackberry is came from an individual little flower. When you talk about a fruit like an apple or a pear or a peach or a mango, all of these don't have fruitlets. They're a single fruit, which means how many ovaries? One. They came from one single ovary within the flower. So you can start to see that flower structure relates to fruit structure. If I went to an apple or a peach, any fruit that is a single fruit, it's not little fruitlets, have one pistil containing a single ovary. Now that ovary can have multiple ovules in it, meaning the fruit has many seeds, or it can have a single ovule in it, producing a single seed. So here, I really like this picture. This is a picture of do you have any idea? Okay, this is the picture of a nectarine, and which is essentially a peach without fuzz, right? So if you notice up here, this is the old flower. Here's the ovary that is growing. It is multiplying in size. I mean, right now it's probably, even though it's a small fruit here, it's probably 100 times bigger than the original ovary was. And you can see up here all the fruit parts. It's lost its petals. You can see the sepals down here, they're kind of brown. You can see these long stringy things. These are the pollen producing structures, the stamen, right? And you can just, so it gives you an idea of this ovary is just growing huge, huge, huge. So you'll go from an ovary that you almost need a magnifying glass to see to a ovary that is potentially that big. You can also see a stigma sticking out. So right here you see this little nub, and you've seen this before on peaches or other fruits. It'll have that little pointy end on one end. That is where the stigma, the style and the stigma were sticking out the top. And you can see the style and stigma right here. It's dried and brown and dead because it's no longer used. This thing's been fertilized already. It's been pollinated already. But you can see all of the flower parts are there on this developing fruit. Again, the shape and the form of a fruit is directly related to the flower. Here we have either, I think this is either a raspberry or a blackberry flower. And let me look at it really quick on the camera, make sure you're able to see that okay. Not the best, but it's not terrible. You can see right here in the center, kind of, you can see that it looks fuzzy. Those are multiple pistils sticking out. And then around the edge of the flower, you have multiple stamens sticking out, right? So you've got a female producing with the ovary in the center, and then all of the stamen on the outside. And what's going to happen is, if these ovaries become pollinated, or if these pistils become pollinated, then they will grow into individual little fruits. So if this is a head inflorescence, right? Like a sunflower, those kind of things. This is a head inflorescence, and each individual flower within this inflorescence will develop into an individual fruit. So now here I can see this raspberry. These look like raspberries here. Each individual little segment came from an individual ovary within the head inflorescence. Hopefully that makes sense to you. If you recall, head inflorescences is made of multiple little flowers that look like a single flower. And if you notice, and you've probably seen this if you've ever paid attention to a raspberry or blackberry when you ate it, sometimes they have little brown fuzzy little strings, not strings, almost look like little hairs coming out all over. Each one of those is the stigma and the style from that pistil that developed into each little fruitlet. So you can see the stigma sticking out of each little fruitlet. And I know it's hard to see on this, especially now that the sun's coming out. Let me see if I can fix that. Okay, that's a little bit better. I will also post the PowerPoint on Canvas, so you'll have access to all these. If you want to go through and look at the PowerPoint while you're playing this, that's probably a great idea. Okay, fruits are divided into two categories, superior and inferior. Okay? In a superior fruit, the ovary is above the receptacle, the petals and the sepals. So this right here is a picture of a superior fruit. Right here is the receptacle of the flower. You can also see that here is the petal, here is the sepals coming out. And right here is the ovary. Okay, there's the receptacle, there's the ovary. In a superior fruit, what that means, superior means above, it means the ovary is above the receptacle. And remember, flower shape and flower structure and fruit structure are interconnected. Peaches are an example of a superior fruit. The fruit develops above the receptacle. When the fruit develops, the flower scars are below. So what's a flower scar? A flower scar is where the sepals and the petals were attached. And if I pull a peach off, I won't be able to see any flower scars on its opposite side. The The flower scars are tucked up inside where the fruit is attached onto the stem. Peaches, apricots, plums, grapes, nectarines, cherries, and there's a whole bunch more, are all considered superior fruits. Any idea what this plant is? I try to stick plants in that are local, and we start learning those. The end of this year is going to be all about plant identification. I'm going to give you, I'm going to show you how to identify plants. I'm going to teach you about identifying plants, and you're going to be required to identify plants and even go out in nature and take pictures of different plants and different plant types. Anyway, this is a choke cherry. So it's an example of a superior fruit. There's no flower scar out on the end of the fruit, which will make sense here in a second. Look at the inferior fruits. Inferior fruits have the receptacle that covers the ovary. The receptacle grows up around the ovary. Okay? Remember, flower structure has everything to do with fruit structure. The sepals and the petals and all that are above the ovary. Here, it's so easy to tell. Inferior fruits will always have a flower scar. So if it has a flower scar, it's an inferior fruit. If it does not have a flower scar out on its end, it is a superior fruit. And if you learn that right there, you can tell, you can look at a fruit and say, oh, this is superior or this is inferior really easily. Apples, pears, citrus fruits, many others are all inferior fruits. Let me see if I can turn off the light for a second so you can see this maybe a little more clearly. Notice, so these are huckleberries, and notice they have this little ring out on the end. What is that ring? Well, that ring just happens to be where the petals and the sepals were attached to the flower before it was pollinated. Once it became pollinated, the receptacle began to grow around the fruit, and as the petals and the sepals fell off, it left this ring-looking structure out on the end. So blueberries and huckleberries are inferior fruits. This is a serviceberry. Serviceberries are really common around here. You're going to need to learn to identify a serviceberry. They look like a miniature apple. They're about this big, not very big fruits, and they have a definite flower scar. In fact, these little structures that are sticking out at the end, any idea what they might be? They are sepals. Yeah. I feel like I'm in one of those kid shows, you know what I mean, where I pause, give you a chance to yell out the answer. I'm sure you're doing that at home, right? Anyway, these are the sepals that are left over. Apples have the same exact thing. I think I've got a picture of those. This is serviceberry. Oh, this one's poisonous. These are found all over our foothills. This is called a snowberry. Really easy to identify because of its white color. And you can see out at the end of each berry, there is a flower scar, meaning it's an inferior fruit. Okay? Apples and pears also have that flower scar. You've all seen it. If you turn an apple on its edge and you look at it, you can see that you can actually still see the sepals attached on to the edge, the end of the apple, or the end of the pear. Okay, let's talk about seeds for a second. So now we know superior fruits and inferior fruits. Superior fruits, no flower scar. Inferior fruits always have a flower scar. Seeds. What is a seed? A seed is a fertilized and developed ovule. It's the ovule within the ovary that has become fertilized and then grown into a seed. That seed obviously can be planted and grow into a new plant. This is how plants do reproduction. Okay, I will put this diagram on Canvas. So you should easily be able to see, or to print this out, or if you want to just do it digitally, however you want to do it. But you will be held responsible for knowing how to label a basic fruit. First of all, we have the endocarp. The endocarp is, it varies in fruits. For example, in a peach, the endocarp is the pit over the seed. Same thing in an almond or a pecan or any of these. There's a really tough, I mean, you almost have to have a hammer to break these open. This endocarp is really, 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 really tough, really hard and very thick, protecting that seed inside. Sometimes the endocarp is papery. In the case of an apple, if you've ever bitten too far into an apple, you notice that you get that papery layer right before the seeds. Sometimes it'll get stuck in your tooth. That papery layer is the endocarp. So it can vary. In some fruits, the endocarp is hard like a pit, like in stone fruits. In other fruits, the endocarp is thin and papery. And even in some fruits, the endocarp is just like a thin membrane is all it is. I'll give examples of that later. Mesocarp. The mesocarp on superior fruits is the part you eat. This is in apricots or peaches or lots of other fruits. In fact, many berries, you are like grapes, you are eating the mesocarp, okay? Generally, it's the fleshy part. Think of a squash, or think of a pumpkin, okay? It's the layer, there's the rind, which is the outside layer, which we call the exocarp. I'll give you two in a second. Then you have the mesocarp, which is the fleshy part, and then you got the seeds inside. Exocarp is the skin. The skin can vary. Sometimes the skin is very thin. In the case of a peach, the skin is fuzzy. Okay, its epidermis is very fuzzy on the exocarp layer. In some fruits, the exocarp might be hard, like for example in a squash. You know, it's the rind and it's really tough and thick. Together, the exocarp, the esocarp, endocarp, and the mesocarp combined are called the pericarp. Okay? So you'll need to know these terms. The seed, which came from the ovule. Whoops. Let me try that again. Holy smoly, what's going on? Okay. Okay, so here we go. The seed, which is in the center, right? It comes from the ovule. The endocarp, okay, is part of the pericarp. The mesocarp, usually what we eat, not always. And the exocarp is generally the skin or the rind of the fruit. I don't really care too much about this. This is just kind of extra information. Okay, so most fruits out there are called a simple fleshy fruit, which means a single ovary developed into a single fruit. Okay, the other exceptions to these are going to be the multiple fruits, which are many individual little pieces like a raspberry making up an entire fruit. Ovaries can be either superior or inferior. They can have just one carpel or multiple. So let's talk about a carpel. I've already mentioned this with flowers. A carpel is a section within the ovary. So take, for example, an apple. If I slice an apple in half, it'll have 5 little compartments inside. Each one of those compartments is called, okay, a carpel. Take a pumpkin or a squash, you cut it, or even a watermelon. If you cut it, you look at it on its end, it will have symmetrical divisions. Each one of those symmetrical divisions is a carpel. Peaches don't have this. Peaches have a single carpel, right? So if I were to cut a peach in half, clear through its pit, I would notice one compartment in the center with a single seed. Okay. Now we're getting into the good stuff. Yes, you will be responsible for knowing all of these different types of fleshy fruits. Fleshy fruits means fruits that are soft, sometimes juicy when they're mature. But when they're fully mature, they are soft. Okay, so we call them fleshy fruits. There's other fruits that are dry fruits. When they are mature, they are hard or kind of crunchy. It'll make sense when we get to those. So we have drupes, pomes, berries. These are all of my simple fleshy fruits, meaning one ovary develops into a single fruit, okay? Then we have non-simple fruits, simple fleshy fruits, which are aggregates and multiple fruits. It'll make sense the difference between these as we go along. Let's start with a drupe. A drupe is a type of simple fleshy fruit, and the easiest way to learn a drupe is that they have a pit, meaning they have a stony endocarp surrounding a single seed. So can you think of examples? Well, I've got one up here, right? A peach. A peach has a stony pit. Usually this is a really hard pit. In order to break this open, you're going to require a hammer or a nutcracker or something like that, because you're not going to break this with your teeth in most cases. Apricots, peaches, almonds. We don't have an area where we grow almonds, but an almond is simply a peach that instead of the flesh getting really thick and juicy and sweet, it stays pretty thin and it's bland tasting. We don't use the exocarp or the mesocarp of an almond. But what we do is, here you can see the exocarp and the mesocarp peeling off, and you're left with a stone in the center. And if you've bought almonds from the grocery store, maybe at Christmas time, and you have to break open yourself, you've experienced this. There's a pit with the almond seed inside. Plums. Here's another one. They have a stony endocarp and a single seed. Cherries, olives. If you get a chance sometime, I really love green olives. On my mission in Argentina, we ate green olives all the time. And all olives have a pit. In fact, when you buy the black olives, they've had that hole put through them. The reason they do that is because they've used a machine to get the pit out. You know, who wants to have to chew the olive off of the pit? But inside here, you're going to have a big pit. You break open that pit, there's going to be a single seed. Oh, here's a great one. Coconuts. What? A coconut is a drupe? Yes, they are. Let me show you a coconut real quick. I attended a luau years ago, and they broke open a coconut, a fresh coconut, and to show us how it's done and how to eat them, etc. And it was super neat and a lot of fun. And they let me keep the husk or the exocarp and the mesocarp for my class. Had a great excuse. So right here, coconuts are green when they're ripe. They turn brown. They're still good when they're brown. So you can get them brown or you can get them green. I think they're a little better green. I've had them down in Mexico when they're green. I'll use a machete and chop all the green part off to get down to the stony endocarp. But you can see here's the exocarp, okay, this outside layer. You open it up, they've got this thick mesocarp that's very fibery, right? We call this core. I think it's C-O-I-R. And core is used a lot. You've probably seen in hanging baskets for plants. A lot of times they will make a core, they'll use the core from a coconut to line a metal wire hanging basket, and then they'll put plants in that. They'll use core as a planting material. It's used to make mats, a whole bunch of stuff. Anyway, here's the core right here, which is the mesocarp. And then the endocarp has been removed on this coconut. So the endocarp would be the coconut that if you go to a grocery store, they've popped it, the endocarp and the seed out from the center. Now, the unique thing about a coconut seed is that it's a drupe with a hollow seed. It's filled with milk. We call that endosperm. And why would a coconut be hollow inside? Why would it have a hollow seed? Well, it turns out that it's got to float. These are often found near water, tropical areas, and the coconut will drop off, land in the water, float off to a new island, sprout, and repopulate new areas. So it's their way of transmitting their seeds around. The white part on coconut, which is the part that's usually, if you buy it, it's been graded. That white part is the actual seed. It's the starch within the seed that you're gonna eat. So coconut's a real fun one. Oops, missed a few. Make sure I got them all. Mangoes. Most people don't realize this. Mango is a drupe. So how does this work? When you eat a mango, there is a seed on the inside of the mango. That seed is not the seed. It's actually a pit. If you break open that pit, it will have a seed inside of it. So mango seeds are really a mango pit when you eat a mango. Pistachios, another fruit we don't really deal a lot with. Pistachios, obviously, we use the seeds in a lot of stuff. They're a seed kind of like an almond or that kind of thing. But the pistachio fruit is used in making different types of foods and that kind of thing. Pistachios, again, they have a pit. You break open that pit and then you get the seed out, which is the pistachio. Okay, here's some stuff that are not nuts. So even though we call lots of fruits nuts, many fruits that we normally call a nut are not really a nut. They're a drupe. A nut is its own category of fruit altogether. An example, though, is a walnut. Look here. If you've ever seen a walnut that's off a tree, they have this skin over them, which is their exocarp and their mesocarp. They then have the stony endocarp, which you've got to break open, and then you get into the seed, which is the walnut itself, which we eat. Pecans. Pecans, another one. Don't grow pecans around here, but this is what they look like. They have exocarp, mesocarp. It dries, it breaks open, cracks open, and what are you left with? You have a stony endocarp, or a pit on the inside. You've got to break open that pit to get that pecan nut out. Very similar to a walnut. So what's important to know there? Some of the things that we call nuts are not really nuts. For example, a walnut, or sometimes refer to an almond as a nut, or sometimes refer to a pecan as a nut. They're not truly nuts. Botanically speaking, they are considered to be drupes. Our second fleshy fruit is pomes. Okay? Pomes are all inferior fruits. They're all going to have a flower scar. When you eat a pome, you are eating the receptacle. You throw away the fruit itself. And that's a really unique thing to do. So, for example, when I eat an apple, the core of the apple that I usually throw away is considered the fruit. The outside of the apple is not the exocarp or the mesocarp that we eat. You're not eating the ovary. It's the receptacle that grew up around that fruit. Okay? We call this an accessory fruit. So really, botanically speaking, now, it won't be this way on a quiz, but botanically speaking, an apple really should be categorized as a vegetable. See, because a vegetable is when we eat the stem, the leaf, the flower, or the receptacle of a fruit, or of, I should say fruit, of a plant. And because it is the receptacle that we're eating, it's really not considered a fruit. Crazy. But for this class, we are going to consider a pome to be the whole thing as a fruit. The ovary is the core. So the actual fruit is the core. In pomes, the endocarp is papery. If you've ever bitten too far into an apple, sometimes you get that papery part stuck on your tooth. That is the endocarp. Examples, apples. So here they've split open an apple. You have the exocarp, which is the skin. Actually, I shouldn't say that. That's the epidermis. You have, it says the floral parts. This part right here, okay? This part of the apple right here, which is the part we eat, this is the receptacle. Okay? This part right here, which we usually throw away, which is the core, is the fruit. So unless you eat the fruit, unless you eat the core of the apple or the core of the pear, you're not actually eating the fruit. Really unique, very interesting. Notice down here, the calyx, right here. The calyx is the flower scar, and you can actually see the sepals sticking out from that calyx. Pears are another example. Rose hips. Rose hips are the fruit on roses. They are edible. However, the receptacle is very thin, so you really don't get very much fruit through them. You don't want to eat the whole rose hip. The interior of the rose hip, the mesocarp and the endocarp of the fruit, are very, very, very hairy. They are hard on the digestive system, and to be disgusting, they actually give people what they call itchy butt, meaning that those hairs, as they pass through the digestive system, they irritate like the anus and the lower colon, and they can make you have to itch. That's disgusting. A lot of people like rose hips tea. I actually really enjoy rose hips tea. You can buy rose hip tea in the grocery store, and all you do is in the fall you harvest these red pomes, not berries. You can see the flower scar on them out at the end. You harvest these red pomes and you basically put them in water, get them really hot. The juices will come out of the pome and turn the water really, really red, and then you are kind of a rosy color, and then you add sugar to it. It's pretty good. Service berries, look at those flower scars. Service berries are a pome. Another one that's really common is black hawthorn. Black hawthorn grow all over the place. Anywhere there's water, there's generally black hawthorn growing. If it's not been too cultivated, if it's wild, there's going to be black hawthorns close by in southern Idaho. And if you notice really carefully, right there, flower scars. It is an inferior fruit. It is a pome. Okay, let's talk about true berries. Okay, lots of things that we call berries normally are not a real berry. Ugh, doesn't this drive you nuts? Botanically speaking, strawberries are not a berry. Raspberries and blackberries are not a berry. We call them a berry because that's just what people come up with, but if we look at the actual definition of a berry, they don't fit the criteria. True berries are divided into 3 categories: true berries, pepos, and hesperidia. All right, I'm going to go ahead and stop there. I'm going to come back and go on this slide. I'm going to discuss this slide again. I'm going to divide this into 2 sections because it is taking a long time to get through all this information. And so we'll divide this into a couple different days of lecture. I hope you've enjoyed this. Please make sure you take notes on this. When we get done with this section, you'll have to put those notes on Canvas. And if you look at Canvas, you'll be able to see that's all there. Thanks for listening and have a great day.